Welcome to EDU World Space.
So in this question, we have been given the following data, right? So the angle of rosette, right, that is equal to 45 degree, and the strain epsilon sub A it's equal to negative 200 into 10 raised to power negative 6. Epsilon sub B is equal to 300 into 10 raised to power negative 6. Right, and gamma sub c is equal to 250 into 10 raised to power negative 6, right? So what we are going to do over here is that we are going to follow the example 10.8, which is similar to this problem, right? And we are going to use the equation 10.6 to find out the strain components that are sigma sub x, epsilon sub x, epsilon sub y, and epsilon sub xy, right? Now, because the rosette is arranged in such a 45-degree pattern, then equation 8.10.8, it becomes that the sigma epsilon sub x is equal to epsilon sub a, epsilon sub y is equal to epsilon sub c, and epsilon sub xy is equal to 2 times epsilon sub b negative the sum of epsilon sub a and epsilon sub c. Right now we are going to substitute these given values into um, into these equations, right? And we'll get our values, right? So the value of the strain that is acting in the x direction is equal to negative 200 to 10 raised to power negative 6. The strain acting in the y direction is equal to 250 into 10 raised to power negative 6, right? And for the strain that is epsilon sub xy, right? So you have the values, you just need to plug them in and you get that's equal to 550 into 10 raised to power negative 6, right? uh, Now from here we find that what we need to build the Mohr's circle, right? So that is the radius of that circle. Now we have the expression for the radius, that is under root the difference of the strain divided by 2 whole square plus the shear strain divided by 2 whole square, right? Again, you have the values, you just need to plug them in. So you plug them in and you calculate that they are equal to 3.5532 into 10 raised to power negative 4, and that is approximately equal to 355.32 into 10 raised to power negative 6. Right now, so now that we have the origin, now we finally need to find out the origin of the we have the radius, right? So we need to find out the origin of the axis, and for that we are going to use the equation that is 10.13, right? So origin of the axis is equal to the average value of the strain, right? So that is the sum of the strains divided by 2. You have the values, plug them in, and you get that's equal to 25 into 10 raised to power negative 6, right? Now all we need to do is to graph the circle, right? Now as you can see over here that this is the point A. Now the state of the strains are occurring at this point, and we need to find out the measure from this. We need to find out the angle. We need to measure the angle from this point, right? So now the principal strains are very easy to find with the help of this circle. Now the principal strain is equal to um, the origin, right, plus the radius, that is equal to 25 plus 355.32 into 10 raised to power negative 6, right? So when you calculate it, you get that it's equal to 380.32 into 10 raised to power negative 6, right? And that is approximately equal to 380 into 10 raised to power negative 6, right? Similarly, we are going to find out the value of the other principal strain, so that is negative radius. You have the values, you just need to plug them in and you get that's equal to negative 330 into 10 raised to power negative 6. Right now, it's not necessary to draw the Mohr circle for this for such problems or for this problem. However, it involves your calculations and it gives you some visual understanding of what is going on, right? Now, it also tells us that this is how the author decided to solve this problem, right? So that is why I'm going to follow this example. Um, I'm following his example, right? And that is why I have solved this question like this. Now you can use the equations, however, if that is where you are most comfortable. This concludes your solution for this question.